So let's talk about the radar navigation. And with radar navigation, it is very important for us or for you to practically know about the principles or the idea or the concept or the novice of the plotting triangle itself. Why? Because it will show you or it will give you the appraisal or the evaluation from yourself whether there will be a collision or not, or what is the true motion, what is the relative motion of that certain target, or which target gives you the riskiest or more risk when it comes to collision. So what is the purpose of plotting? It can show whether danger of collision exists, how close will pass the target, and how much time there's left before this will take place. Approximate determination of the course and speed of the other vessel or the target, and sensible avoiding action can be taken when needed. Manual plotting in connection to radar means to mark one or more echoes within a specific time interval and thus decide the target's movement in relation to ownership. For that, gentlemen, manual plotting only occurs if the ARPA fails. Okay? If the ARPA fails, then you can do manual plotting. Because radar, it requires the radar transfer plotting sheet because you have to observe the bearing and you have to take the range. While for ARPA, it gives you all the required information already. Okay, the objective of plotting is to obtain the clearest possible picture of the situation. Another objective, let me add on this one, is for you to determine which is the relative motion and the true motion, and what will happen with that certain motion while observing it. So these are the plotting process. The plotting process are the following: detection, selection, tracking, and plotting. For the detection, it's the recognitions of the target. For the selection, you have to choose which targets require closer observation or which targets gives you more risk when it comes to collision. And for the tracking, it's the process of observing or monitoring that target. And of course, the plotting is the process of detection, selection, tracking, and calculation of targets parameters. What are those parameters? Of course, we've mentioned earlier in a few weeks, CPA, TCPA, bow crossing range, okay? And of course, the aspect. What's the aspect? What is the bearing of that vessel? How much degrees is it on my port side? How much degrees is it on my starboard side? Will it overtake me? Will it cross my bow, or I will cross her bow? Okay, is it a head-on situation? Do I see her port side? Do I see her starboard side? So that is the requirement or the meaning of the target aspect. So on the presentation proper, the aspect is defined as the angle of view. However, in connection with plotting, we will use the term calculated aspect in order to distinguish between the two. It can be defined as the angle between the target ship's heading and bearing to own ship as seen from the target ship. In connection with the plotting and use of radar and ARPA, we'd better define what we receive from these systems as calculated aspect. When you say calculated aspect, it does not necessarily mean it is exact or it is accurate. Okay, calculated or estimated aspect. Now, looking on the compass rose, you have your vessel. It's colored blue. Okay, let me maximize. And you are on a heading 030. 030. However, there's a vessel on your starboard bow bearing 070 degrees. That is the true bearing. Okay, true bearing. But the relative bearing of that vessel is only 040 degrees because you are heading 030. So you just subtract. Okay. And here's how it looks like in a real situation. If you're on the own vessel, you can see the angle in degrees of that target vessel. So for that situation, they are passing starboard to starboard. Okay, when it comes to selection, we have a drawing here wherein which you should be watching out and which should you be not confident or complacent, but at least continuously monitoring it. On the port side, there's an aspect 45 degrees relative. However, it is on your starboard bow. Do you see this vessel? With this one, you have to take care. You have to be careful with your decisions. And of course, the point of MX. With this example, if she is on the starboard bow and you are both power-driven vessel, that means she is the stand-on vessel. And with that, you have to alter your course or you have to alter your speed. Now, on the right side, aspect is the same. It's 45 degrees relative. However, it is on your port bow. And you are heading approximately 090 degrees. Okay, so all targets with red aspect on port side and with green aspect on her starboard side are usually no danger targets because you can see her port side. Okay, and all targets with red aspect on our starboard side and with green aspect on our port side are the targets we need to watch out for. Okay, so here's a plotting triangle. Again, there's what you call the R, the M, the E, and then the M. Of course, R to M is the relative motion or the echo line or the relative track of the target. E to M, it's the target's ship's course and speed. And E to R, that is your own course and speed. Okay, here's the terminologies, basic terminologies with the ARPA or with the radar ARPA itself. CPA, relative motion line, RML, NRML, or the new relative motion line after your alteration of course. And SRM is the speed of relative motion. It's the length of the R to M. It is measured from that triangle. And the DRM, it's the direction of relative motion or the R to M itself. And the MX, of course, the position of the other ship on RML at the planned time of evasive action or the point of execution. That means you will be the ones executing the alteration. Okay, that is your point of MX. Mostly that happens, point of MX happens when the vessel is on your starboard bow and you are both power-driven vessels as per Rule 18. Responsibilities between vessels should apply. Here is an example diagram of the closest point of approach. Vessel on starboard bow. This is your bow crossing range or bow crossing point. From your bow up to this point, it's your bow crossing point. But of course, this is your CPA. Why is it there? It's because it is 90 degrees. 90 degrees on from the relative motion line. Okay? And this line is drawn up to the center of the vessel because normally the GPS itself is installed on the Monkey Island. Kung ano yung nakikita nyo dito sa starboard picture, this is the main mast or the aft mast. Monkey Island is there. And of course, TCPA. Let's include TCPA from the point of that vessel up to the CPA. It will be your TCPA. So we're talking about time. If we talk about time, there's the formula, basic formula. We have the DST. Does anyone know what is the DST formula?
Yung 0.1, sir.
Wrong. DST formula is as shown on the slide. You can copy it. Distance, speed, and time. Distance equals speed times time divided by 60. If speed is required or the required speeds are required, for example, if you want to arrive at a certain time, we're talking about the ETA, distance divide time times 60. Okay, and for the time, distance divides speed times 60. 60 because in 1 hour, it's 60 minutes. Okay, these are the radar plotting rules called nautical mile range. Kapag if you will be using radar transfer plotting sheet, it should be in north-up orientation and 6-minute rule. For the video, I will just show you later. Let's skip this part. Okay. Trial maneuver function. Okay, all ARPA have this one. Radars have the functionality called trial maneuver, where you can set the new course to set the new CPA, TCPA with all the acquired targets. This is a wonderful tool to know the course speed to change to maintain a certain CPA with the target. But this functionality is only required for radars fitted on vessels more than 10,000 gross registered tonnage. GRT means 10,000 gross registered tonnage. So mayroon siyang trial maneuver. Kapag kinlik mo yon, you will see what will happen with the CPA and TCPA. And you can even increase for how many minutes that you will be able to determine it. And here's the performance requirements. Trial maneuver, it should be above 10,000 gross tonnage. Okay. And here on this slide, you will see in a picture, but which is not clear because I just copied it online. But I will show you, gentlemen and lady, if there's anyone. This is what you call the vector. Ito ay returned echo. This is the returned echo. This is a returned echo. It's colored almost yellow. Okay? This is your own vessel. Yellow. This is yellow. And this blue ones is the trails. Remember this, gentlemen, on your practical or laboratory, your professor might ask you. So this is trails. This one is the vector. Okay, vector. Understood?
Yes, sir.
Yes po,
Okay.
sir. Yes.
Yes. Okay, sa vector na yan at saka sa trails na yan, meron tayong tinatawag na true and relative. Okay? For the true and relative part, I will not insert the explanation for that one for this week because you might be confused if I'm going to inject the knowledge about that. But at least now you know what is vector and you know what is trails. But with the difference between true vector and relative vector and true trails and relative trails, it has something to do with the way you navigate or the way you carry your vessel. Okay? Aside from the trial maneuver itself, okay? Aside from the trial maneuver itself, with the use of the true and relative vector and the true trails and the relative trails interchangeably, you can navigate as safe as is possible. Okay? Ginagamit ko to. I'm using this on board. So I'm sure you will learn a lot if you know how to use those ones. Okay. Let me escape this one. I'm going to give you an activity. Okay. Okay, everyone, screenshot. Screenshot. Paki-screenshot to and gawin nyo sa radar transfer plotting sheet. Your ship is on course 345 degrees. Speed is 15 knots. You know the following radar contact at 0830. Contact bears 329 degrees through at the range of 9 miles. And another 6 minutes after that, same contact bears 326 degrees at a range of 6 miles. What will be the CPA? What is the contact's relative speed? What is the contact's true speed? When the range of the contact drops to 4.5 miles, you want to change course. Contact passing on your port side with a new CPA of 2 miles. What is your ship's new course? Okay, gentlemen and ladies, kung mayroon man, paki-screenshot and do it on your radar transfer plotting sheet and reply it to me. I will send you later how you will submit it to me. Understood?
Yes, sir.
Yes,
sir.
Asuncion, what is your
Yun lang po yung deadline po niyan, sir.
ngayon, maaga pa naman eh kasi madali lang naman to, hindi to, this is not the hard part. Okay?
Sir,
So,
thank you po.
do it. Kaya ba? Kaya? Kaya?
Hindi po.
Bakit?
Printan, sir.
Ay, wala kayong radar transfer plotting sheet?
Bago, sir.
Babu, sir.
Okay. Sige, assignment na lang. I'll just send you on the canvas itself. Pero paki-picturean nyo na lang siguro at least, tapos gawin nyo na lang. Assignment na lang. Okay? And for next week, for the week 9, I'm going to teach you the true vector, relative vector, true tails, relative trails, and the track. Okay? Kung paano gamitin yon, kasi napaka-vital nun. Kung hindi nyo matutunan, you will not be able to navigate properly. And baka kasi hindi maituro ng ibang professor or instructor sa laboratory nyo, kung sino man siya, baka turo-turo lang, hindi kayo matututo. No? Sayang. No? That's the reason why I'm teaching here in Our Lady of Fatima University. And one more thing, no? A little professionalism with the GC chat. Kasi we're doing our class asynchronous. It's not because I'm always absent. I'm just trying to compress my time kasi I'm also working with other company. Okay? So, but I am really trying to give you everything, injecting everything when it comes to our lecture itself. No? So don't worry. I will teach you properly. Even if it's just online for me. Sa part ko kasi lecture lang. Sayang, no? Kung lecture and lab sana, mas maganda yun. Mas matututo kayo. Okay? May question tayo? Class?
None po, sir.
Answer.
Okay. Okay, kung wala, let me just screenshot yung attendance. One moment. Let me stop the sharing.